minimum clear distance required around the enclosure of a 4160 volts to 480 volts transformer is determined by the National Electrical Code, specifically Table 110.34 in the 2005 edition of the NEC Handbook. This table addresses the minimum depth of clear working space at electrical equipment. Understanding and adhering to these requirements is crucial for ensuring the safety of personnel working on or near electrical equipment, as well as providing adequate space for maintenance and operation. To determine the correct working space, one must consider several factors, including the voltage of the equipment, the condition of the installation, and whether the equipment is accessible to unqualified persons. In this scenario, a 4160 volts to 480 volts, 1000 kilovolt amps, dry type, three-phase transformer is situated within a chiller building and is not serving as the service entrance. The transformer is housed in an enclosure with vent openings only, meaning that energized parts are not exposed. Given these conditions, Table 110.34 becomes applicable. Table 110.34 outlines different conditions that affect the required working space. These conditions typically depend on the voltage to ground of the equipment and the nature of the opposing surface. The conditions are designed to address different levels of risk associated with working near energized equipment. Condition 1, as referenced, generally applies when the exposed live parts are operated and not over 150 volts to ground and were insulated. Alternatively, Condition 1 may apply when grounded parts are on one side of the working space and exposed live parts are on the other side. Condition 2 typically applies when exposed live parts are on one side and grounded parts are on the other side. Condition 3 generally applies when exposed live parts are on both sides of the working space. The specific distances prescribed in Table 110.34 are designed to provide a safe working environment for qualified personnel who are trained to work on or near energized electrical equipment. It is important to note that the table provides minimum distances, and in some cases, it may be necessary to provide additional working space beyond these minimums to accommodate specific site conditions or operational needs. In the case of a 4160 volts transformer, the voltage to ground is a critical factor in determining the required working space. Since the transformer is stepping down voltage from 4160 volts to 480 volts, the higher voltage side is the determining factor for working space requirements near the transformer enclosure. Consulting Table 110.34 for voltages in the 4.16 kV range, assuming Condition 1, often indicates a minimum clear distance of 3 feet. This distance is measured horizontally from the enclosure to any opposing surface, such as a wall or another piece of equipment. If the transformer is accessible to unqualified persons, additional safety measures may be required, such as barriers or locked enclosures, to prevent unauthorized access to the equipment. The term unqualified persons refers to individuals who have not received the necessary training and certification to work on or near energized electrical equipment. If the transformer is not accessible to unqualified persons, the 3-foot minimum clear distance requirement is likely sufficient, provided that Condition 1 is applicable. However, it is essential to verify the specific requirements of the 2005 NEC Handbook and consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. Furthermore, it is important to consider other factors that may affect the required working space, such as the presence of obstructions, the type of work being performed, and the qualifications of the personnel involved. Obstructions, such as pipes or ducts, can reduce the effective working space and may require adjustments to the installation to ensure adequate clearance. The type of work being performed may also necessitate additional working space, particularly if the work involves complex tasks or requires the use of specialized tools or equipment. The qualifications of the personnel involved are also a critical consideration, as only qualified persons should be permitted to work on or near energized electrical equipment. To ensure compliance with NEC requirements, a thorough assessment of the installation should be conducted by a qualified electrical engineer or inspector. This assessment should include a review of the equipment specifications, the site conditions, and the applicable codes and standards. The engineer or inspector can then provide recommendations for ensuring that the installation meets all applicable requirements and provides a safe working environment for personnel. In addition to the minimum clear distance requirements, the NEC also addresses other aspects of working space around electrical equipment, such as the height of the working space, the illumination requirements, and the access requirements. The height of the working space must be sufficient to allow personnel to stand upright and move freely. The illumination requirements are designed to ensure that the working space is adequately lit to allow personnel to safely perform their tasks. The access requirements are designed to ensure that personnel can easily access the working space without having to navigate through obstacles or hazardous areas. The NEC also addresses the use of barriers and enclosures to protect personnel from electrical hazards. Barriers can be used to prevent accidental contact with energized parts, while enclosures can be used to house electrical equipment and prevent unauthorized access. When selecting barriers and enclosures, it is important to choose products that are appropriate for the intended application and that meet all applicable safety standards. Regular inspections and maintenance of electrical equipment and working spaces are also essential for ensuring continued safety and compliance with NEC requirements. Inspections should be conducted on a regular basis to identify any potential hazards or deficiencies. Maintenance should be performed as needed to correct any identified problems and to ensure that the equipment is operating safely and efficiently. In summary, determining the working space around a 4160 volts to 480 volts transformer requires careful consideration of the NEC requirements, the site conditions, and the qualifications of the personnel involved. Table 110.34 provides guidance on the minimum clear distance requirements, but it is essential to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. Furthermore, regular inspections and maintenance are essential for ensuring continued safety and compliance. The specific voltage levels mentioned, such as 4160 volts and 480 volts, are important factors. The higher voltage of 4160 volts typically dictates a larger minimum working space compared to lower voltage systems. This is because higher voltages pose a greater risk of electrical shock and arc flash, requiring more space for personnel to safely work around the equipment. The 1000 kV amps rating of the transformer is also relevant. Larger transformers generally require more working space due to their physical size and the potential for more complex maintenance procedures. The fact that the transformer is a dry-type transformer is also a consideration. Dry-type transformers are typically used indoors and may have different ventilation requirements compared to liquid-filled transformers. These ventilation requirements can affect the placement of the transformer and the required working space around it. The location of the transformer in a chiller building is also important. Chiller buildings often have specific environmental conditions, such as high humidity or temperature variations, which can affect the performance and safety of electrical equipment. These conditions should be considered when determining the working space and selecting appropriate equipment. The fact that the transformer is not acting as the service entrance is also relevant. Service entrance equipment typically has stricter working space requirements due to its role in providing the main power supply to a building. Since this transformer is not the service entrance, the working space requirements may be slightly less stringent. The enclosure with vent openings only is also a key factor. This type of enclosure provides some protection against accidental contact with energized parts, but it does not completely eliminate the risk. Therefore, adequate working space is still required to ensure personnel safety. The reference to the 2005 NEC handbook is important. Electrical codes are updated periodically, and it is essential to use the correct version of the code for the specific installation. The 2005 NEC handbook may have different requirements compared to more recent editions of the code. The minimum clear distance of 3 feet, as suggested by Table 110.34 or Condition 1, is a common requirement for electrical equipment operating at these voltage levels. However, it is crucial to verify this distance with the actual table and to consider any other applicable factors. Accessibility to unqualified persons is a critical safety consideration. If the transformer is accessible to unqualified persons, additional safety measures, such as locked enclosures or barriers, are required to prevent accidental contact with energized parts. The NEC defines qualified persons as those who have the skills and knowledge related to the construction and operation of electrical equipment and installations and have received safety training to recognize and avoid the hazards involved. Unqualified persons are those who do not meet these requirements. In addition to the minimum clear distance, the NEC also specifies other requirements for working space around electrical equipment, such as the height of the working space, the illumination requirements, and the access requirements. The working space must be of sufficient width and depth to allow personnel to safely perform their tasks. The height of the working space must be at least 6.5 feet or the height of the equipment, whichever is greater. The illumination requirements specify a minimum level of lighting to ensure that personnel can see clearly and avoid hazards. The access requirements specify that the working space must be readily accessible and free from obstructions. The NEC also addresses the use of personal protective equipment, or PPE, when working on or near energized electrical equipment. PPE includes items such as insulated gloves, safety glasses, and ARC-rated clothing. The type of PPE required depends on the voltage level and the potential hazards involved. Regular training on electrical safety is essential for all personnel who work on or near electrical equipment. This training should cover topics such as the hazards of electricity, the proper use of PPE, and the procedures for working safely on energized equipment. Lockout/tagout procedures are also an important part of electrical safety. These procedures are used to de-energize electrical equipment before it is worked on and to prevent accidental re-energization. Lockout/tagout procedures involve placing a lock and tag on the disconnecting means to indicate that the equipment is being worked on and should not be energized. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in electrical equipment. Arc flash can cause severe burns, blindness, and even death. Arc flash studies are often conducted to assess the potential arc flash hazard at a particular location and to determine the appropriate level of PPE required. Electrical safety is a shared responsibility. Everyone who works on or near electrical equipment has a role to play in preventing accidents and ensuring a safe working environment. By following the NEC requirements, using PPE, and receiving proper training, it is possible to minimize the risks associated with working with electricity. It is also important to remember that electrical equipment should only be worked on by qualified persons. Unqualified persons should not attempt to repair or maintain electrical equipment, as this can be extremely dangerous. If you are not qualified to work on electrical equipment, you should contact a qualified electrician to perform the work. In addition to the NEC, there may be other applicable codes and standards that must be followed. These may include local building codes, state electrical codes, and industry standards. It is important to be familiar with all applicable codes and standards before working on electrical equipment. The information provided here is for general guidance only and should not be considered a substitute for professional advice. If you have any questions about electrical safety, you should consult with a qualified electrical engineer or inspector.